A group of 7 students queue in a straight line at a canteen to buy a drink. In how many ways can a queue be formed? This example, we're going to pay attention to using the factorial notation. But just quickly, what it means is the following. There's a formula. The number of ways to do a queue is the number of ways is, of course, how many people are a factorial. And factorial means n. If there's 7 ways, 7 times 6 times 5 times 4. If I have a queue and there's 7 people, then the first place there's 7 possible ways, 6, 5, 4, 3, 2, 1, and therefore it's 7 factorial. So that's where it comes from. So the number for 7 people to queue is 7 factorial. That you can do in your calculator, or you can say 7 times 6 times 5 times 4 times 3 times 2 times 1, which you do in a calculator. If you don't have a calculator, you do it in your head, and you say that's 540. So that's for A. In B, they say, what's the probability that the students carry their drink then to a circular table? In how many different seating arrangements can the students sit around the table? Now, I'm not going to go into detail, but what it comes down to is that it's a lot to do with the arrangements. So if I have 7 people, there's going to be less options, because although this person can move to that spot, if this is person 1, this person 2, once person 1 moves there and person 2 moves there, it is still the same arrangement. So what I'm going to do is I'll have to divide by 7 at the end. But in a circle, the number in a circle is definitely different. The formula that we use is a formula that you have to remember. It is n minus 1 factorial. There are 7 people in the circle. Take away 1 factorial. That's 6 factorial, which means 1 times 2 times 3 times 4 times 6 times 5 times 4 times 3 times 2 times 1, and that answer equals 720. So it's 720 ways. The last one took me a while just to get everything right. So this group of students then have been shortlisted for the mathematics, history and arts prizes. My first thing was, if I have history, there's 7 different outcomes. Then for each one of the maths, and for each one of those there's arts, which means there's 1 and 7, 1 and 7, 1 and 7. So that's one way of thinking about it. But then there's also 7 students that this can happen. So this method, 1 and 7, 1 and 7, 1 and 7, would have worked if they say for a specific student. But this question say for any one of the 7 students. So although there's a 1 in 7, 1 in 7, 1 in 7 way, which means 1 times 7 times 1 times 7 times 1 times 7, there are 7 different people that can use it, so this will be times 7. The other way that we can quickly look at is the probability of getting for a person, for a specific person to do this, will be the number of those divided by the number of the sample space. Let's just quickly look at that. If there's 3 prices, let's go back to this box table, divide by, and remember we have these 3 prizes. The total of the sample space, any 7 people, there's 7 choices, 7 choices, 7 choices. So underneath my line, I have 7 times 7 times 7, because the same person can get the prize again, and that's why this is not 765. 7 people can win, second prize 7 people, third prize 7 people. For us to get to this condition where it's one singular person, it means that in our first choice, the first prize can be any one of those 7. But then, if we want only one person to win, our second choice can only be the same person as whatever this person was at the front. So there's only one possible outcome, And for the third prize, there can only be one prize. So the 7 times 1 times 1, which you will see works out exactly the same as what we've done here. This 7 cancels with this 7, so we have a 1 in 49 chance for the person to win.